Hi Algebra 1, this is our last video before our quiz. This is section 7.4. This is actually day 2 of that section. And we're going to be looking a lot at the greatest common factor. And so if you recall, the greatest common factor of 24 and 60 is the number that can divide into 24 and 60 evenly, and it's the biggest out of all of those numbers. For example, 1 can go into both of them, 2 can go into both of them, 3 can go into both of them, etc. So some people like to just make a list like what I'm doing now. Some people like to make a factor tree, and there's even some other methods that I'm sure you've seen before, and we can talk about those in class. But you get up to what I like to do if I do make a list. 1 and 24 both go into 24, 2 and 12 both go into 24, 3 and 8. I like to sort of match them up when I make a list like that. I guess our only other ones are 4 and 6. We'll go ahead and put those. So for 60, so the highest number that could be the GCF is 24, but 24 does not go into 60. 12 does. 12 actually goes into 60 5 times. And so 12 is our GCF. So whether you make a list or a factoring tree, again, we'll talk about some of those methods when we get into class. So we are going to look at greatest common factors of numbers, and I'll show you why in just a second. But we can also look at the greatest common factor of variable expressions. So for example, look at x to the third and x times y and say, what do they have in common? Well, I see an x in both of those expressions. This one has 3 x's technically. This one only has 1. So our GCF is just that 1x that we can pull out of both. So let's look at these. I see we have some x's and y's and some z's. Let's see how many. This one only has 2 x's, this one has 10. So at most we can pull out from both of those is x squared, 2 x's. This one has 6 y's, this one technically only has 1, and so we can only pull out 1 y. You can call it y to the first if you want to, or just y is fine. This one has 3 z's, and this expression has 4 z's, so at most we can pull out of both, there's 3 of them. We can't pull out all 4 because this first expression only has 3. And so technically that is our GCF. So it's a little different finding greatest common factor when there's variables involved. I'll let you guys try the checkpoints. We'll go over those in class. Now here's why we use the GCF when we're working with polynomials. We're actually going to do the distributive property, but backwards. So we are going to find out what's in front being multiplied by our parentheses. What is in front is always going to be your GCF. So look at 24 and 60 again. Well, we already found up above that our GCF was 12. Look at x to the third and just 1x. So at most we can pull out is an x. And there are no y's in either of those expressions. So this is the only thing that will pull out to the front of the parentheses. So 12x. To find what's left over inside the parentheses, let's work backwards from distributing. So 12 times something would produce 24. 12 times 2 would give us 24. X times how many more x's would we need to get x to the third? 2 more x's. We already have 1 out in front. 2 more would make 3. Plus 12 times what is 60? 12 times 5. X times, well, I don't need any more x's, I already have one of them. And I need a y, so we'll call it 5y. If you want to check your answer, what you can do is just go through and distribute like normal. So we would get 24, x times x squared would be now x to the third. You'd have 3 x's. 12 times 5 is 60. And x times y, we would just multiply those together. And so your final answer is what you see up here. The GCF in front of the parentheses, and they're being multiplied by 2x squared plus 5y. Let's try another one. You'll get really fast at this. I know that was kind of slow. But if you take 3 and 18 and look for a GCF, 3 is your GCF. How many a's can you pull out of both? Well, there's 2 here, but there's 4 here, so at most we can pull out is 2. Now we're going to say what's left over. 3 times what is 3? Okay, that's only 1. There's an a squared here, but I already pulled out an a squared, so I don't even need any more a's. Minus 3 times what is 18? 3 times 6. And I need an a to the fourth. Well, I already have a squared, so how many more do I need? I need 2 more. And again, if you want to check your answer, just go through and multiply. Let's see, 3 times 1 is 3, a squared, minus 3 times 6 is 18, a squared times a squared would now be a to the 4th, and so we are correct. This is your final answer here. And again, I'll let you do the checkpoints, and we'll go over those in class. Have a good day.